Hi, my name is Wan Amira Zafira. I am from class J4EE114B1. Today, I would like to present 4 types of questions about op-amp. Let's take a look for the first question. Figure Q1 shows a subtractor circuit. Assuming the op-amp is idle, determine the output voltage V0. So, as we can see here, the question is only obtain one op-amp. First thing that we need to do is find the value of V plus and V minus. As we can see here, the value of V plus can be obtained by applying VDR. So 1K over 1K plus 2K multiple with 9 volt here. So we obtain the value of V plus is 3 volt. The value of V plus is equal to V minus. So V minus also obtain 3 volt. Next, by applying current in and current out, we can find the value of V0, which is I1. Here is I1, and here is I2. So I1 is equal to 10 minus 3 over 1K equal to I2, which is 3 minus V0 over 1K. So we calculate the equation and we get the value for V0 is negative 4 volt. Okay, now let's proceed to the solution of question 1. So this solution is for figuring out whether the calculation is correct or not. Okay, first let's find the op-amp first. So I choose this as my op-amp. Just place it here. And next, the resistor. This question using 4 resistor, so I just put here, here, and here. Okay, so this one I just okay, I just connect all the resistor to the op-amp. Okay, now we add the power source. Try to make it nicer, make it neat. So here, add the ground. This ground is for the multimeter. Okay, so this power supply is connect to the ground, and here also connect to the ground. Okay, so this voltage is equal to 10 volt. So this one is 9 volt. Okay, this resistor is equal to 1K. Okay, this resistor is 2K. Okay, this resistor 1K, so no problem. So this resistor is 1K also 1K. Okay, now to figure out whether the Vout is correct is similar to the calculation, we add this multimeter. Okay, the positive side connect to the output and this negative side connect to the ground. Now we run the simulation, and yes, the value of the simulation is similar to the calculation. Now let's take a look for the question 2. Figure Q2 shows a combination of 2 operational amplifier circuit. Determine the output voltage of V output 1 and V output 2. Assume all op-amps are idle. Okay. First thing that we need to do is to consider A1. Okay, just look at the op-amp in here first. Okay. First thing that we need to do is to find the value of V plus. By looking at the circuit, we can apply VDR to find the value of V plus. Okay, by applying the VDR, 18K over 18K plus 30K times with 3 volt here, we get the value of V plus is 1.125 volt. So the value of V plus and V minus is the same, which is 1.125 volt. Next, to find the value of V output 1, we can use current in equal to current out, which is current in here, I put as I1, current out here, I put as I2. Okay, I1 is equal to 5 minus 1.125 over 120k equal to current out, which is I2, 1.125 minus V output 1 over 300k. So we calculate the equation, we get the value of V out 1 is negative 8.56 volt. Okay, next, let's consider A2. By looking at the circuit, there are two voltage here. So I apply the superposition theorem to find the value of V plus, and using the superposition theorem to find the value of V output to here. Okay, first, by applying the superposition theorem, we need to on only one voltage at one time. Okay, first thing, I only on the V out 1 here, so the other voltage I connect to the ground. So in here, at here, I applying the VDR to find the V plus value. So by applying the VDR, 15k over 15k plus 20k times with negative 8.56 is equal to negative 3.7 volt. So the value of V minus is equal to V plus. So by applying the current in and current out, I obtain the value of V output 2 here. So I3 is 0 minus negative 3.67 over 27k equal to current out I4 negative 3.67 minus with V out 2 over 56k. So the value for V out 2, which is the first voltage on V out 1 here, is negative 11.28 volt. Okay, next, consider the V out 1 is connect to the ground and the 0.7 volt is on. Okay, so as usual, by applying VDR, we can get the value of V plus. Okay, applying the VDR 20k over 15k plus 20k times with 0.7, we get the value for V plus is 0.4, which is the same as V minus. So apply the current in and current out, which is here and here. So current in I3, 0 minus with 0.4 over 27k is equal to current out I4, 0.4 minus with V output 2 over 56k. So we get the value for V output here is 1.23 volt. So to calculate the value, all the value of V output 2 at the op-amps A2 is V out 1 here plus with V out 2. So negative 11.28 plus with 1.23, we get the value for V out 2 is negative 10.05 volt. Okay, now let's take a look the solution for question 2. Okay, as you can see here, the space already full with the components that needed in question 2. So the things that need to be done, just the connection. Okay, so let's connect all the components. Okay, so this one is connected to the ground. The 5 volt also connected to the ground. This 5 volt connected to the 120k, 3 volt connected to 30k. This one is connected to V plus here, 120k is connected to the V minus, 300k connect here and connect with the V output here. Okay, this one 18k is connected to the V plus here. Okay, next look at the 20k connect with the here, and another part is connect with the V plus here. Okay, so 27k connect with the ground and connect with the V minus. This one also connect with the 27k and connect with the V output here. Okay, so 15k here connect with the 0.7 volt and connect with the V plus. So all of the components are already connected. So next we need to do is put the multimeter. So we obtain the value for V out 1 and V out 2. Okay, you can make put here first and put here. So the positive one we connect with the V output, and the negative one is we connect with the ground. Okay, same goes with this multimeter. Connect with the positive side, connect with the output, and the negative connect with the ground. Okay, so we run this simulation to find out the value for the V output 1 and V output 2. Okay, so we run this simulation. Okay, so as we can see here, the value of the V output 1 and V output 2 is similar with the calculation. So this means that the calculation is correct, since the simulation and the calculation is obtain the value is the exact value, which is for the V output 1 is negative 8.562. For the V output 2 is negative 10.051 volt. Okay, now let's take a look for question 3. Figure Q3 shows an instrumentation amplifier circuit. Calculate the output voltage, V out. Assume all op-amps are idle. So as we can see here, the circuits obtain 3 op-amps. So let's calculate the value for voltage output for every op-amps one by one. So first thing, let's consider A1. Okay, as we can see here, the value for V plus in A1 already be assigned, which is 10 volt. So automatically the value for V minus is also 10 volt. So by applying current in and current out, we can obtain the value for V output 1, which is here. So I assign the current in, which is I1, which is here. This is I1, and current out, which is I2, which is here. Okay. So the equation for I1 is V out 1 minus 10 over 1.5k is equal to current out I2 10 minus 5 over 1.2k. So we calculate the equation and we get the value for V out 1, which is 16.25 volt. Okay, next, let's consider A2. So in A2, the value for V plus is 5 volt. So automatically the value for V minus also 5 volt. So by applying current in and current out, we can find the value for V output 2, which is here. Okay, so the current in is I2, the current out, which is here, is assigned as I3. Okay, so the equation for I2 is 10 minus 5 over 1.2k is equal to current out I3 5 minus V out 2 over 1.5k. So the calculation for the equation and the value for V out 2 is negative 1.25k. Sorry, 1.25 volt. Okay, next let's consider A3. So as we can see here, in this circuit, the value for V plus or V minus doesn't sign anything, so we don't know the value for V plus or V minus. So what we can do for find the value is, by applying VDR, we can find the value for V plus. So by applying VDR, which is 1.5k over 1.5k plus 1k times with negative 1.25 is equal to negative 0.75 volt. Okay, so we already obtained the value for V plus, which is negative 0.75 volt. It's also the same as value for V minus. Okay, so by applying current in and current out, we can find the value for V out. So I assign here is I4, which is the current in, and I assign I5 as the current out here. Okay, so the equation for I4, which is current in, 16.25 minus with negative 0.75 over 18k is equal to current out I5 negative 0.75 minus with V out over 18k. So we calculate the equation and we get the final answer for V out, which is negative 17.75 volt. Okay, now let's do the simulation for question 3. So as you can see now, in the space, all of the components that contained in question 3 are now in the space. So now what we're gonna do is connect all the components. Okay. So let's connect this 10 volt with the ground, and this 10 volt also connect with the V plus here. Okay, so 5 volt connect with the the 5 volt connect with the ground here, and this 5 volt is connect with the V plus here. Okay, so this here connect with the resistor 1.5k, 1.5k connect with the 1.2k, 1.2k connect with the 1.5k, and the 1.5k connect with the output of the 1 pump here. So this V minus here is connect with the connect with this here, and this V minus connect with here. Okay. So next, the 18k here connect with this 1.5k. Sorry. Okay, my bad. Sorry. Okay. Connect here. And this R here. Sorry, 18k connect with this 18k, and this 18k connect with the output here. Okay. So the V minus here is connect these two resistor, and this one is connect with the, also connect with these two resistor here. Okay, this one connect with here. Okay, this 1.5k connect with this ground. Okay, so as you can see, all of the components already connect with each other. Now let's put the multimeter to identify the value of the output. So the positive connect with the output, and this negative connect with the ground. So we run the simulation to check whether the output obtained for the simulation is similar with the calculation. So we run. Okay, so as you can see here, the value for output that obtained from this simulation is negative 17.746, which is quite similar with the calculation just now. So this the proof that the calculation just now is correct. Now for the last question. Calculate the output voltage of Vout1, Vout2, and Vout3 for the circuit shown in figure Q4. Assume all operational amplifiers are idle. Okay, so as we can see here, in this circuit there are 3 op-amps. Let's find out the value for Vout1, Vout2, and Vout3. First thing that we need to do is consider A1. Since V minus is connected to the ground, the value for V minus is 0. So automatically the value for V plus is also 0. So what we need to do is by applying current in and current out, we can find the value for Vout1. So the current there is 2 voltage at V plus. So what we can do is I1 here and I2 here. By summing up I1 and I2, we can find the value for current out, which is I3 here. So the equation for I1 is 4 minus 0 over 2k plus I2, 2 minus 0 over 2k is equal to current out, which is I3, 0 minus Vout1 over 1.5k. So we calculate the equation and we get the value for Vout1 is negative 4.5 volt. Okay, next, let's consider Vout2. As we can see here, the connection for the V minus is connected to the 2 volt. Automatically, the value for V minus and V plus is 2 volt. We also can see that the connection for V plus is connected directly to the Vout2, which means Vout2 is equal to 2 volt. Next, let's consider A3. Okay, A3 also obtain 2 voltage, which is Vout1 here and Vout2 here. So what we can do is by applying current in and current out, as we can see here, V plus is connected to the ground, which means the value for V plus and V minus is 0. So by applying current in current out, which is I4 here and I5 here, which is this is I4, this is I5. Summing up these two current, which is current in is equal to current out, which is I6 here. Okay, so I4 is negative 4.5 minus 0 over 1k plus with I5, 2 minus 0 over 2.4k is equal to current out, which is I6, 0 minus Vout3 over 2k. So we calculate the equation. We get the value for Vout3 is 7.33 volt. Okay, now for the last simulation, question 4. So as you can see here, all of the components are already included in this space. So what we can do now is connect all the components. So let's connect all of the components. So we can get the value for Vout1, Vout2 and Vout3. Okay, this 2 volt connect with the ground, and this 4 volt also connect with the ground. So this 4 volt connect with 2K, 2 volt connect with 2K also here. This 2K connect with the V plus. This 2K also connect with the V plus. So this V minus is connect with the ground. Okay, so this 1.5K connect with the V plus also and connect with the V output 1 here. Okay. So next the V minus is connect with the 2 volts here. This V plus connect with the output here. Okay, so 2.4K here connect with output here and connect with the 1K here. So this V minus connect with the okay, connect here. Okay, so 2K here connect with the this V minus. Okay, and this 1K is connect. This 1K connect with the V output here. Okay, so this 2K connect with the V out3 here. So the V plus here is connect with the ground. So let's put the ground here. Ground. Okay. So all of the component is already connected. Now what we need to do is put the multimeter to identify the value for Vout1, Vout2 and Vout3. So put here for Vout1 and put the multimeter here for Vout2 and the last multimeter here for Vout3. So let's connect the multimeter to find out the voltage output. This one, sorry, okay, this one is connected here. This one is connected here. Okay, so this V plus connect here, and this one connect with that. The ground also connect with the negative. V plus connect with the out here. Oh, sorry. Okay, now let's run the simulation to check the value. So as we can see here, all of the value is similar with the calculation just now. So the V output 1, we obtain negative 4.5 volt, which is similar to the calculation. The V out2 is 2 volt, which is same as the calculation. And the last one, V out3, 7.33, also the same as the calculation just now. So as we can see here, all of the value are same with the calculation, which means the calculation is correct. That's all from me. Thank you.